partial quotients method of long division is different from the traditional long division that we learned when we were students. So the thing about traditional long division is that it does work well for students. Some students really like it. They like having the steps, they remember the steps, and they use them with fidelity. But other students, long division can be a sticking point. They can't remember the steps. It does not make sense to them. And the partial quotients method for some students can be very helpful, and it can kind of shed light on the entire division idea. So we're going to go through, I will explain exactly what it is and how it works. This first part is not what I would expect the students to do. This is what I show them at the beginning so that they understand what they're doing with division in general. So right here, I have 189 dots. And so I'm doing 189 divided by 7. So the idea here with partial quotients is that I can take groups of 7 that are easier for me and then subtract them from the total. So let's start here. I know 7 times 10 is 70. I also know 7 times 20 is 140 because we've worked with multiplying multiples of 10. So here I might start and I might say, I know that 7 times 10 is 70. So I know that there are at least 10 groups of 7 in this mix. I could even make a second group like I showed you in the other example. So now I know I had 10 groups up top. Now I have 10 more groups of 7. And then I'll know that I have 49 left over. So when students are doing this, they will make groups of whatever size makes sense to them. So typically they will start with 10, or they might do 5, or any multiple of 10, 20, 30, 40, 50, etc. If we're working with larger numbers, then they might start with multiples of 100. So the idea is that they're taking out groups and they know how many groups of 7 that is, and then we're left with 49. So here they might jump straight to, okay, 7 times 7 is 49. That's a fact that I know. I add together all the groups I made. I made 10 groups plus 10 groups plus 7 groups equals 27 groups. They could have also split it up a different way. So let's say at the beginning they can see clearly, they could pull out 20 groups, and then they will see what they have left. They still have 49 left, and maybe they go for 5 groups of 7. So they have their 35 here, and then they are left with just 14, which is 2 groups. So again, we have 20 plus 5 plus 2 equals 27 groups again. So what would this look like if the student was writing this? Because I do not want them drawing out 189 dots. Absolutely not. That would take way too long. So the first thing they do is they write it kind of like a normal long division. On the left hand side here, they've written just what we would typically see, but over here is where they are writing the partial quotient. So the method comes from the fact that you're dividing some of the total at a time. So they've written 20, they have this, they're going to do that subtraction. Okay, they get 49. Now they are dividing this group. So now they say, okay, I made 20 groups of 7. Now how many groups of 7 can I make? Like in that other example, they might just make 5. So then we have 49 minus 35 is 14. And then that's just the 2 groups. And then we're all the way done. So when they are finding their answer, they're adding together those numbers and they are getting 27 groups. So this is the way they would record their work. All right, and let's look at how this compares to the traditional method. In this method, you are also getting 27 as your answer. So I like to show the students that no matter how you do it, as long as you're using a method correctly, you will get the right answer. So to me, I have no personal preference on what they use, but I need them to use a strategy that consistently works for them and gets them the correct answer. What you will notice here that can be difficult for some students, especially if they don't know their facts, is right here, there is no room for them to say, I don't know how many groups of 49 I can make with 7 exactly. I must know it is exactly 7. I have to know that. I cannot say, well, I know that I could make 5, okay, like over here. So this is where this method can work better for some students because they don't have to have those facts completely memorized. Over here, if they don't have the facts memorized, then at this step, once they have the 49 left over, they might be over here trying to figure out 7 times what equals 49. And for some students, that could be quick and easy. They could easily figure out that fact if they don't have it memorized. But for other students, they might be writing out 7 bubbles and putting in tally marks until they get to 49 or some other convoluted strategy that would take a lot of time and be frustrating for the student. So here, this can help some students because they do not have to be exactly correct. In the first example I had showed you with the dots, they could even have done 10. So they could have 10, 10, 5, and 2, and then they'll still add it together and get 27. So why would students use this if they are well versed in the long division method? These sorts of problems where you have really easy numbers are going to be easier to solve using partial quotients than writing out all of the long division steps with the divide, multiply, compare, subtract, compare, bring down. With those steps, this is not going to be, that's not going to be as fast for this because they could easily see, okay, I can do, 3,000 groups of 3 and then just one more group of 3. Okay, same thing here. They could be thinking, okay, I know 25 times 4 is 100, so then I'll just have one more group of 25. So that strategy can be helpful if students know to use it in these sorts of situations so they're not taking a lot of time writing out all those long division steps. Of course, students are always welcome to do whatever strategy works for them. This is just presented as an alternative. Okay, so common errors and issues with this method. One of the common problems is adding incorrectly at the end. If they have a really long string, sometimes they will miss a number and add incorrectly. So that can be addressed by helping the student to become more organized, using lined paper to do this so that each number is on a line, circling the numbers as they go, or some other strategy of that nature. Writing numbers in the wrong place can be problematic for both this method and traditional long division. They need to know that they're writing the number of groups over here. So sometimes you will see a student and they will write the 140 over here instead, and that is just with more practice and showing them other examples. Forgetting to subtract can be problematic as well. Sometimes students kind of get into a trance where they're just writing things and not really thinking about what they're doing. And then this is probably the biggest issue with this method. They will just say 1, 1, 1, 1. So they'll just subtract 7 at a time or 2 groups or something like that instead of trying to find those easy benchmark numbers like multiples of 10, fives, etc. So again, these are all issues that can be resolved. If this method works for the student, then these issues can be easily solved.